Here's the word cooker. How many different arrangements of the 1, 2, 3, 4, 5, 6 letters can we find that are different? Well, we could start out saying, well, this is the permutation of 1, 2, 3, 4, 5, 6 letters, taken 6 at a time if we need to use all the letters. And that, of course, would end up being 6 factorial. However, when we have these two O's in cooker, we could, for every different ordering, we could switch places with the O's and you wouldn't know what happened. You could switch the O's in every single one and it would never look like a different answer. So we would have to divide this by, it will turn out 2 factorial. So this would give us 2 factorial, and that would give us 6 times 5 times 4 times 3. The 2 and 1 will cancel out, and that will give us 6 times 5 is 30 times, well, you want to do 12. That comes out to be 360. Okay. We cut it in half because we had double letters. Well, let's see what happens if we go to an even more repetitive word. Let's look at the word pepper. P-E-P-P-E-R. Now here's 1, 2, 3, 4, 5, 6 letters. So you'd think we might start out with 6 factorial. However, we do have repeating letters. We have 2 E's. So every time we see an E, we could switch it and we wouldn't know it. So we have to divide out just like we did with the O's in cooker. So we'll divide that and we'll call that 2 factorial. 2 times 1 is still 2. But look again, we also have 3 P's. Now if we have 3 P's in a problem, we could rearrange them lots of different ways. How many do you suppose? How many ways could we order 3 different things? Well, it turns out to be 3 things taken 3 at a time is 3 factorial. So if we have 3 P's, that means we can't tell the difference in any one of them, and 3 factorial is the number of ways the P's can be arranged, and that comes out to be 3 times 2, or 6. But that's 3 factorial. So we divide out each of these repeating values. 2 E's says you have to divide by 2. 3 P's says we have to divide by 3 factorial. And so we wind up with 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. And then we've got 2 times 1 over here. We can cancel the 3 2 1s. And then we can take 2, multiply it in and make that a 2. 2 divides 2 once. 2 divides 4 twice. So now we have 6 times 5 times 2. This turns out then to be 60. There are only 60 different ways to rearrange all 6 letters of the word pepper so that you can tell that you've got a different arrangement. Many more than that if you could tell the different letters apart, but since you cannot, we have to do this division.